The investigation into the Mitsubishi A6M3 specifically manufactured as a Model 22, begins with a catastrophic loss of airspace control. From October 1943, Allied forces intensify a concentrated bombing campaign against Japanese airfields across southern Bougainville, continuing the attacks through the November landings. The operational objective is total airspace denial and the physical elimination of enemy aviation assets on the ground. Caught on the ground at the Kara airstrip, this specific Zero fighter is seriously damaged during the Allied bombing campaign. The attack permanently degrades the structural integrity of the airframe, dropping it below the minimum safety thresholds required for flight. This ground destruction establishes an absolute operational constraint. Allied naval and aerial superiority subsequently isolates the local garrison from any reliable logistical support. Replacement wings, factory tooling, and specialist engineering assistance become effectively unavailable, although occasional Japanese courier aircraft still reach southern Bougainville. The damaged airframe is stranded at Kara. The damage mechanism forces an immediate tactical decision by the local ground crews. Its lightweight skin and internal structure were vulnerable to blast and fragmentation, but the precise pattern of damage recorded at Kara is no longer known. No surviving record identifies the precise repair requirement. The local command must now evaluate a severe trade-off. Leaving the shattered aircraft on the open ramp guarantees it will be repeatedly strafed and incinerated by Allied air patrols, wasting a vital source of raw materials. Consequently, Japanese personnel move the disabled fighter away from immediate exposure and conceal it at or near the Kara airstrip. This concealment decision initiates a massive gap in the operational history of the machine. The aircraft remains hidden in the jungle for 18 months. Moving the wreck under the thick canopy successfully protects it from direct aerial observation, but it immediately introduces a severe environmental constraint. 18 months of continuous exposure to tropical humidity, torrential rainfall, and daily thermal cycling fundamentally alters the physical condition of the airframe. The humid environment creates ideal conditions for corrosion, particularly where moisture remains trapped or dissimilar metals meet. Pitting, galvanic attack, and corrosion within vulnerable aluminum alloy components become persistent risks, although the exact extent of deterioration during the aircraft's concealment is not recorded. Unprotected magnesium components within the engine accessory section begin to pit and crumble away. Rubber fluid hoses and critical hydraulic seals become extremely brittle, completely losing their required elasticity. The stranded Japanese garrison faces extreme deprivation and an acute shortage of engineering supplies. Damaged aircraft scattered around the area become an essential reserve of interchangeable components. The surviving record does not establish that this specific Zero was systematically stripped during its concealment. Instead, other wrecks would later provide the parts required to rebuild it. By the end of this prolonged isolation, enough of the original structure survives to make reconstruction possible if suitable components can be recovered from other wrecked Zeros. The next problem is procedural: how to turn the surviving structure and components recovered from other wrecks into one serviceable aircraft without factory support. Approximately 60 to 70 Japanese naval maintenance personnel remain in the area, forming the limited workforce from which the reconstruction team must be drawn. Stripped of mechanized lifting equipment and external electrical power, this sheer manpower requirement becomes an absolute operational constraint at the isolated Bougainville garrison. To reinforce morale and restore technical purpose within the stranded unit, the local command authorizes an unusual rebuilding project. The crews begin assembling one serviceable Zero from aircraft damaged around Kara. The effort is not purely symbolic. By the end of July 1945, Petty Officer Sekizen Shibayama is flown from Rabaul to test the reconstructed fighter and, if it proves airworthy, ferry it back to Rabaul. The surrender of Japan intervenes before that flight can take place, leaving the completed machine on the ground at Kara. The central engineering challenge is the creation of a composite airframe from distinct, separately damaged aircraft. The rebuilt fighter retains the identity of Mitsubishi manufacturer number 3844, whose number is associated with the original rear airframe. A data plate bearing the number 3835 is later found on the engine bearers, indicating that the forward structure contains major components from that aircraft and may include much of its forward fuselage. This deliberate combination of surviving sections defines the composite reconstruction. Under field conditions and with limited equipment, the mechanics must bring the principal structures into workable alignment and reconnect the systems required for flight. The precise jigs, supports, and alignment methods used at CARA are not recorded, but the surviving repairs show that the work was completed with considerable skill. With the major sections selected, the mechanics adjust mismatched components and incorporate surviving panels from other aircraft wherever required. The exact fastening sequence and configuration of every field repair remain unconfirmed. What survives inside the aircraft is clear evidence of bomb damage repair and extensive component substitution, but not a complete engineering record of how each joint was produced. Beyond restoring the external structure, the ground crews must reconnect the mechanical and electrical systems required for operation. Control runs, engine services, cockpit equipment, and landing gear mechanisms all have to function across a machine assembled from several donors. Parts from other damaged Zeros provide the essential supply of components. The precise origin of every cable, instrument, hose, and fitting is no longer known. This exhaustive manual labor produces a visually complete and apparently serviceable fighter. It has no documented post-repair factory certification, but the surviving evidence does not justify treating every fastener or structural joint as defective. However, the physical existence of this fully assembled weapon system immediately introduces a new tactical hazard. Once this undocumented structural mosaic was completed, how could it be protected from immediate destruction by advancing Allied forces at the end of the war? The completed fighter remains at CARA when the war ends. Its existence is not entirely unknown. Reports of the aircraft reach Royal New Zealand Air Force intelligence personnel based at Piva, prompting a visit to the airstrip after the Japanese surrender. No surviving account establishes that Allied disarmament patrols were under a blanket order to destroy it on site. Its survival instead depends on the orderly surrender of the area and the decision of New Zealand personnel to inspect and recover the aircraft. As hostilities end, the Zero receives the conspicuous surrender markings used on a number of Japanese aircraft. Its military camouflage is covered in white paint, and large green crosses are applied to the wings and fuselage. The scheme identifies the aircraft as operating, or being held, under surrender conditions, rather than as an active combat machine. It provides a clear visual indication of non-hostile status, but it does not create a legal guarantee of protection or automatic authorization for flight. Executing this administrative requirement introduces a new localized logistical constraint. The ground crews lack proper depot-level painting facilities or standardized aviation coatings. They must manually apply whatever white pigment they can source directly over the uneven, mismatched exterior panels of the airframe. The dense white paint covers the irregular splice joints and non-standard fasteners, completely obscuring the complex history of the machine beneath a uniform layer of surrender markings. With the site legally secured, specialized technical evaluation becomes the immediate priority. On September 15, 1945, Wing Commander William Kofod of the Royal New Zealand Air Force and Engineer Officer C.D. Kingsford arrive at CARA in a Wirraway belonging to No. 5 Squadron of the Royal Australian Air Force. Their objective is to inspect the surrendered Zero and determine whether the Japanese field repairs have left it serviceable. Kofod and Kingsford carry out a practical visual and mechanical inspection. questioning the Japanese pilot about the aircraft and its repairs. Japanese personnel run the engine, allowing the New Zealanders to judge the fighter's general condition and apparent serviceability. Kofod and Kingsford judge the repairs well executed and the equipment apparently serviceable, but no surviving account records a hydraulic pressure test, a compression measurement, or a formal structural certification. The Zero remains a surrendered enemy aircraft at Kara, not yet a registered Allied asset. Recovering it will require either a difficult dismantling and surface transport operation, or a decision to risk flying it. With the airframe administratively secured and proven functional on the ground, what operational risk would be required to physically extract it from a remote jungle strip? Subjecting an uncertified field-repaired aircraft to the dynamic loads of actual flight forces, an extreme calculation of risk. While the static ground inspection confirmed the mechanical continuity of the captured fighter, evaluating a stationary machine cannot replicate the intense physical stresses of takeoff and flight. The airframe rests at the remote Kara airstrip, where recovery by land would be difficult but not physically impossible. The official alternative requires dismantling the fighter, moving its sections over rough roads to the coast, and carrying them onward by barge. The Surrender Commission rejects a proposal for Shibayama to fly the aircraft and reportedly directs that nobody is to take it into the air. Wing Commander William Kofod nevertheless decides that the Zero should not be abandoned at Kara. After inspecting the machine, he chooses to fly it to the Royal New Zealand Air Force Base at Piva in defiance of the no-fly instruction. Because the aircraft has been assembled from multiple damaged machines, its repair history is not supported by Allied maintenance records or structural calculations. Takeoff and flight will load the landing gear, wings, fuselage, control system, engine installation, and repaired structure simultaneously. Those loads will pass through numerous interconnected skins, frames, longerons, fittings, and fasteners rather than through one isolated splice joint. A failure in any critical structure or control system could still make the aircraft uncontrollable. Kofod therefore relies on the inspection, the engine run-up, the Japanese pilot's answers, and his own judgment that the repairs appear serviceable. Kofod accepts the risk and proceeds. 2 drums of fuel are produced and hand-pumped into the Zero, after which the engine receives a further tune-up. Kofod takes off from Kara and begins the 32-minute flight northwest to Piva. He leaves the undercarriage locked down for the entire journey, reducing the risk of a malfunction in the unfamiliar landing gear system. The route still carries him over difficult Bougainville terrain, but the surviving account does not establish that he deliberately flies at extremely low altitude or through hostile airspace. The formal Japanese surrender has already taken place. Despite the uncertainty surrounding the field repairs, Kofod lands safely at Piva after 32 minutes in the air. The uneventful journey demonstrates only that the aircraft is serviceable enough for that single flight. It does not prove the long-term fatigue strength of every repaired component or provide formal certification of the reconstruction. Kofod's decision preserves the aircraft for further examination, while also earning him a reprimand for disobeying the order that it was not to be flown. After the successful extraction, the Zero remains at Piva while Royal New Zealand personnel and equipment are prepared for repatriation. Its engine is run several times, but it is not flown again on Bougainville. For shipment to New Zealand, the propeller and tailplane are removed, and the partially dismantled fighter is loaded aboard the inter-island ferry steamer, Wahine. The vessel leaves Bougainville on October 15, 1945, and reaches Auckland on October 20th. From there, the Zero is unloaded and carried by barge to Royal New Zealand Air Force Station Hobsonville. Upon arrival in New Zealand, the aircraft enters a more systematic engineering evaluation. Hobsonville personnel are instructed to carry out a 90-hour inspection, make the fighter serviceable, and prepare a provisional maintenance schedule for possible exhibition flying. The airframe and engine are found to be in generally good condition, although weak brakes, corrosion in several wheel bearings, a poor port tire, and deteriorated instrument panel shock absorbers require attention. The central obstacle is not a complete absence of maintenance planning, but the lack of replacement parts and usable Japanese servicing information. Sustaining the aircraft in regular service would require reliable access to compatible parts, servicing instructions, and personnel able to interpret its Japanese technical markings. RNZAF attempts to obtain suitable spares through personnel in Japan are unsuccessful. A group of Japanese prisoners of war is also asked to help interpret the labels and servicing instructions, but they are not aviation specialists and cannot translate the technical material. Without dependable spares or usable documentation, continued flying becomes increasingly impractical. Before the final grounding decision, the Zero flies once more. Around December 12, 1945, Wing Commander A.E. Willis, the commanding officer at Hobsonville, conducts a flight lasting approximately 10 minutes and reports that the aircraft is pleasant to handle, with no unusual traits apparent during the brief test. Proposals to use it for exhibition flying or tactical training nevertheless fail to secure lasting approval. On May 6, 1946, the Air Department permanently grounds the Zero and restricts it to demonstration and exhibition use, transforming it into static surplus property that no longer requires dynamic load testing or engine ground runs. The aircraft initially remains in storage and is later transferred to No. 1 Technical Training School, although it is never meaningfully used for instruction. For a period, it gathers dust inside a hangar, but by the early 1950s, it has been placed in open storage. Weather, children, and souvenir hunters inflict further damage on the already vulnerable machine. It is displayed at public events, partially dismantled, moved between storage sites, and only later returned indoors. The post-war years therefore preserve the Zero, but they also erase components and add new layers of damage and modification. Recognition of the aircraft's historical value begins before its final delivery to a museum. In the late 1940s, the Royal New Zealand Air Force offers the Zero to the Auckland War Memorial Museum, whose curator accepts it, but asks that the aircraft remain in Air Force custody until suitable exhibition space becomes available. The promise is nearly lost during the following years of storage and proposed disposal. On November 30, 1959, 12 years after the original offer, the aircraft is returned to Auckland. Following further refurbishment, Royal New Zealand Air Force personnel deliver and assemble it at the Auckland War Memorial Museum, finally completing the earlier transfer. Yet the aircraft no longer carries only the white surrender finish applied in 1945. During its post-war storage and exhibition history, it receives several new and historically inaccurate paint schemes, including a blue or blue-green finish, and another hurried repainting for the Royal New Zealand Air Force anniversary display at Ohakea. These successive layers obscure both the earlier wartime colors and portions of the aircraft's physical repair history. Decades later, conservators and researchers must separate the evidence of the Kara reconstruction from alterations added during its post-war life. Physical examination can reveal evidence that incomplete wartime records cannot provide, but it rarely reconstructs every repair with absolute certainty. In 1985, researcher Peter Lewis publishes a detailed study of the Auckland Zero's history and composite identity through the Aviation Historical Society of New Zealand and the Auckland Institute and Museum. The aircraft's extensive physical refurbishment takes place a decade later. In 1995, the Zero is removed from display and treated by Aircraft Component Engineering in preparation for the Auckland War Memorial Museum's Scars on the Heart exhibition, which opens in 1997. The work combines cleaning, conservation, limited reconnection of controls, examination of surviving components, and reproduction of an earlier wartime paint scheme. During the later research and refurbishment, investigators record the production numbers and repair evidence visible on surviving components. These markings allow several panels and assemblies to be linked to other Mitsubishi Zeros. Protective treatment is also applied to interior and exterior surfaces. No surviving public account establishes that every panel, internal frame, fastener, and linkage was removed and cataloged before cleaning. As researchers examine the surviving structure, the scale of the composite reconstruction becomes increasingly clear. The aircraft retains the identity of manufacturer number 3844, but numbered components reveal material from several other zeros. The port gun chute access panel bears the number 3217, while a port wing root access panel is marked 3278. Components carrying the number 3616 include the upper engine cowling, the upper engine accessory panel, gun port and gun blast panels, and the starboard gun chute access panel. A data plate marked 3835 is attached to the engine bearers and may relate to much of the forward fuselage. Together, these findings confirm that the surviving machine incorporates identifiable material from at least 5 aircraft, although the origin of many unmarked parts remains unknown. Discovering parts from at least 5 aircraft creates a complex conservation problem. The zero contains wartime structure, Japanese field repairs, donor components, and alterations introduced during decades of post-war storage and exhibition. During the 1995 refurbishment, the team cleans the aircraft, reconnects some controls, and applies conservation and protective treatments to its surfaces. The earlier wartime color scheme is revealed and reproduced, while visible evidence of bomb damage repair and composite construction remains part of the artifact. Some panels, however, appear to result from later post-war work, making it impossible to describe the displayed aircraft as untouched since Kara. The surviving production numbers secure only part of the aircraft's provenance. The markings cannot reconstruct every step taken by the Japanese mechanics or separate every wartime repair from later post-war alteration. Countless unmarked brackets, fasteners, cables, and panels remain anonymous, leaving the artifact to preserve both a remarkable engineering achievement and an unavoidable limit. In a composite aircraft rebuilt under wartime conditions, the absolute origin of every component may never be known.